In this problem, we're given a polynomial function in factored form, and we're asked to determine the x and y intercepts of the function. So for a quick review, in general, to determine the x-intercepts, we set y equal to 0 and solve for x, and to determine the y-intercept, we set x equal to 0 and solve for y. And remember, in function notation, f of x is equal to y. So let's start by finding the x-intercepts of our function, which means we'll set y equal to 0, or in this case, f of x equal to 0, and solve for x. So we would have 0 equals the quantity x minus 2 times the quantity x plus 1 times the quantity x minus 4 times the quantity x plus 3. Well, this product will be equal to 0 wherever each factor is equal to 0. So for example, x minus 2 is equal to 0 when x equals 2. X plus 1 is equal to 0 when x equals negative 1. X minus 4 is equal to 0 when x equals 4. And x plus 3 is equal to 0 when x equals negative 3. So these x values represent our x-intercepts. Technically, we shouldn't leave it in this form because these equations actually represent vertical lines. So we can say the x-intercepts equal 2, negative 1, 4, and negative 3. Or we can also list them as ordered pairs, which I prefer. If the x-intercept is 2, the coordinates would be 2, 0. If the x-intercept is negative 1, the coordinates would be negative 1, 0. If the x-intercept is 4, that would be the point 4, 0. And if the x-intercept is negative 3, the point would be negative 3, 0. So here are the x-intercepts of our polynomial function. Now let's determine the y-intercept. To determine the y-intercept of the function, we set x equal to 0 and solve for y. Or in this case, because it's written in function notation, we want to determine f of 0. So we would have 0 minus 2, that's negative 2. 0 plus 1 is 1. 0 minus 4 is negative 4. And 0 plus 3 is 3. This product will be our y-intercept. So negative 2 times 1 is negative 2, times negative 4 is positive 8, times 3 is equal to positive 24. So there are two main ways to express the y-intercept. We can say the y-intercept equals 24, or given as a point, it would have coordinates 0, 24. And then of course to verify this, we can graph the function. So let's take a look at the graph. Notice how we do have 4 x-intercepts at negative 3, negative 1, positive 2, and positive 4 on the x-axis, and our y-intercept does look like it's 24. So the graph does verify our work is correct.